Hi, my name is Dean, and this is my CS50 final project called TriTracker. First, a quick piece of background on the technology I've used to pull this together. It's reminiscent of the tools from problem set 9, as you'll see from some of the menus here. So it's Python and HTML with Bootstrap extensions for the menus, all running in Flask. I've also published this onto the web using Render, so it's accessible directly from a browser or from a mobile device. I'm using the entry-level tier on Render, which resets itself every so often. So what I've done is I've persisted the data in a persistent data store, a SQL-like database, so that we don't lose the data each time and don't have to continually refresh and recall Strava. I'm also using the free Strava tier. The Strava tier uses open authentication to pull in data. It's a throttled service. It has a basic setup, which I'll show you just quickly here. There's a client ID and a client secret setup, and it monitors usage with a relatively low read rate. But I've set this up as a single user application, just for myself. Relatively easy to extend to multi-user, and again in the same way that problem set 9 was done. But that's a bit of repetition that I didn't feel I needed because this is just a personal project. So as a user, first things first is to connect to Strava. If I wasn't already logged into the Strava connection, it would ask for a login at this point, and the open authentication is allowing us to do that without the application itself ever knowing what my username and password is. The first time on load, there's no data, and there's a sync with Strava button, so each time that a user comes in, potentially weekly, to look at the data, they press the sync with Strava button, and what that does is it goes out and it reads the latest set of data. So the last week, for example, worth of activities. The first time it does this, I have several years of Strava data in here. It takes about a minute to load everything. So while it's doing that, let me talk you through what the landing page looks like. So a user coming in having already synced with Strava, pulled the data in, storing that data in the local SQL-like database, we'll see something that looks like this. They'll see the current week's distance, the time, the number of sessions, and then an overview of what they've done over the last weeks, months, or quarters. To make this work, I'm using leaflet.js for the maps, charts.js, which gives super simple, very little code to create a reasonably cool looking analysis over time, so the athlete can look and see how they're progressing over time. And I've also added an average function, so looking at last week versus the preceding 4 weeks. I had an interesting bug as I was coding this up that I had 0 decimal places and got a 0%, and just in actual fact, I did almost exactly the same time last week as I did for the previous 4 weeks. So I had to add a decimal place just to make sure that the maths was right and to show some differences. The map's also zoomable. We can zoom into the map, we can see the different exercises done. The colours match, so a run is red and a cycle is blue. Zoom in and zoom in and zoom in. And then we can differentiate between my rides, my runs, which are always round about the same place and round the same park, and any swims that are done open water, which I don't do any open water swims, they're all in the pool, so they don't have a location. So that's the high level dashboard. You can see during the import process, 1100 odd activities were imported. We can look at those individual activities. So these are the individual activities that are recorded in Strava. We pull in and store the date, the sport type, which gives us the red or the blue icon here. Distance, time, pace, and where relevant, elevation. So this particular run, 0 elevation because it was flat. Some of these indoor rides had their indoor elevation associated with them. We can dig into these further. We dig into a recent one. This was a cycle done in Italy a couple of weeks ago, 53 kilometers, time, distance, elevation, what Strava calls a suffer score, so time, pace, watts, elevation together to give a score. And then here's the map of that particular ride. Then what we do is we lazily fetch this data, so when we build the initial data import, we don't pull all the data in for every single activity because that would take forever to pull, because this is a relatively high resolution data feed down to a few meters. You can see the individual kind of corners that we took. What we do is we only fetch this data, and then we update the database with this data with that lazy fetch when we look at an individual activity. We don't ever have to go back and fetch that again because it's stored in the database. There's a tab for overall trends, so how are we doing? Let's look at riding over the last quarter. You can see it's been a good, the last 3 or 4 quarters have been good. A little drop off in the pace at the end. We can kind of zoom back into that and say, well, the last couple of weeks has been slowing down. There's been a couple of weeks with 0 activity, so we just leave those blank. And then we capture the elevation, so we can kind of show not just the distance, but the kind of effort that's gone into things. For a swim, again, no elevation on swim, so we won't show that. And the key thing, the exciting thing that I wanted to do out of this, that's great, pulling data. You could just do this on Strava. I wanted to build a predictor component. So using a little bit of maths, looking at different distances, so a 10k run, a half marathon, all the way up to a full Ironman, predicting with a confidence score about finish time. So you can see roughly over the last few weeks, I had a 107, 108 finished prediction time. That's gone down to now 110, so I've lost 3 minutes in the last few weeks. The maths that we use for this, let me quickly show you there's marathons, and then when we look at triathlons, I've hard-coded and baked in the T1, the transition times, using standard assumptions, because my race times don't give those standards for how long do you take to get out of your swimming costume and into your bike gear, how much do you take to get out of your bike gear and into your running gear. So it hard codes those, but then we add the rest of the time together to give a rough confidence. The methodology, this is just static content about how we do that, looking at a 90-day training window, looking at average speeds and distances, looking at the race distance, looking at penalties, a confidence score. So if we don't have enough activities, how do we calculate the value? So there's an interesting methodology. Going back to the predictor, it's close. My actual best 10k time in the last couple of weeks is 46 minutes. So that's a little bit out. It doesn't really consider in this piece things like altitude and gradient on the runs. It just looks at the absolute pace. But for Ironman, 14:56 estimate with 50% confidence. My Ironman time is 14:45, so it's pretty close as an estimate to what realistically could be done. And finally, I've left one setup page in here for how to connect with Strava as a user, so it doesn't require any technical knowledge. We've already set the API connectivity up and made that available. So if I clear this and let another user, can log out of this, let another user connect, it will connect another user, and they can then access their own data. So that's been CS50, this has been TriTracker. Thank you to all the staff and faculty, this has been a fantastic experience.